Geometry, moving into a new chapter, chapter 7. What we're going to focus on first are finding different angles of polygons or finding angles of different polygons. And what we're going to focus, the two angles we're going to focus on are the interior and the exterior. Okay, so interior and exterior. So let's focus on things that we know. We know that a quadrilateral, let's talk about a square. We know that a square, if I added all of the angles up inside of a square, there's going to be 4 90-degree angles. And so that's going to be 4 times 90, which is going to give me 360. Now that's easy because we know the angles of a square, but what if we didn't know the angles? Well, there's actually an interior angle sum formula for any convex polygon, and that is 180 degrees, 180 degrees times n minus 2. And n stands for the number of sides. Okay, so let's look at that for our square. If we had 180 times 4 minus 2, that's 180 times 2, which gives me 360. So that's the easiest way to look at it, that one that we actually know, but it works for a pentagon, hexagon, octagon, nanogon, any of those. Now, exterior angles, all of the sums, the exterior angle sums total 360 degrees. So it doesn't matter what size of shape it is, all of the exterior angles added together are going to give me 360 degrees. And so let's look at some examples maybe out of the book. Let's say I don't want to do that one. That one's pretty easy. Well, let's look at an octagon. I'm going to do a regular octagon. Do I have an octagon up here? I sure don't. Let's just do a hexagon. Okay, so I'm going to do a regular hexagon. And what if I wanted to find what one of those angles are, not knowing anything else other than all of the sides are equal and all of the angles are equal. So this is a regular hexagon. And so I'm going to use my 180 times n minus 2. That's my interior angle sum theorem. And in place of n, I'm going to put 6, because it's a hexagon. Oops, 6 minus 2. So that's going to be 180 times 4, which is 720. That means all 6 angles add up to be 720. So if I wanted to find out what just one of them was, I would divide by 6. And so one angle is going to equal 720 divided by 6, which is 120 degrees. I should one interior. One interior angle is 120 degrees. Now, to find an exterior angle, all I do is take the total, which is always going to be 360, and divide that by 6. And so each exterior angle is going to be 60 degrees. Now, notice something that should make sense. If I add my exterior angle plus my interior angle, they should equal 180 degrees. Because if I extended this side, I don't like that extension. If I extended this side, here is my interior angle, and here is my exterior angle. So those should total 180 degrees every time on any shape. So let's look at something a little bit different. Let's take it one step further. What if we knew the sum of the interior angles was 540 degrees? What if I knew the sum of the interior angles was 540 degrees? How many sides are on this polygon? So remember that our formula was this. Okay, the sum equaled 180 times n minus 2. So now we just take 180 times n minus 2, and since we know the sum, we just substitute that value in there. And so now we can do some distributive property. That's 180n minus 360 equals 540. And now we just solve for n because n is going to be the number of sides. So I'm going to add 360. And so I get 180n equals 900. Then I'm going to divide both sides by 180. And the number of sides is going to equal 5. So that is a regular pentagon. So that is Chapter 7, Section 1, Angles of Polygons.